In question 1, we have to write down the inequality shown by each of these number lines. So in A, here the arrow is pointing towards the right of -3. All numbers to the right of -3, of course, will be greater than -3. So we know that x will be greater than -3. However, the dot tells us that we must include -3 as well. So all numbers greater than or equal to -3. So we need an equal to sign here. So x is greater than or equal to -3. In B, the arrow is pointing to the left of 4. So we know that x is less than 4 because all numbers to the left of 4 will be smaller than 4. The circle here tells us that we must exclude 4. So we won't write equal to as well. So here x is strictly less than 4. Then in C, the line is drawn between -2 and 5. So we know that x must be greater than -2, but less than 5. We have a dot at the 5, and that means we must include 5. So it can also be equal to 5. So x is greater than -2, but less than or equal to 5. In question 2, we have to illustrate the inequalities on a number line. And in A, we have x greater than 2. So x strictly greater than 2. So we can start by drawing a number line. And we can indicate 2 on it. Now x must be strictly greater than 2. So we know that the arrow will point to the right of 2 for numbers greater than 2. And note that we are not including 2. So we need a circle at 2. In B, we have x less than or equal to -1. So we can draw the number line. X less than -1 tells us that the arrow must point to the left of -1, to numbers smaller than -1. And then x can also be equal to -1. So that means that we need a dot at -1. So x less than and equal to -1 includes all the numbers smaller than -1 as well as -1 itself. In C, we have x greater than or equal to -3, but strictly less than 3. So let's draw the number line. So x must be between -3 and +3. So we need a line between those two numbers. Then x is greater than or equal to -3. So we're going to use or need a dot here at -3. Then x is strictly less than 3. That means that we're not including 3. So we need a circle at 3. In D, x is greater than or equal to -1, but less than or equal to 4. So we know that x is between -1 and 4, and therefore we need a line between the two numbers. X also includes -1 and 4, so we need dots at -1 and 4. In E it says x is greater than -2, but less than or equal to 2, and x is an integer. Now, we know that the integers are represented by the symbol z, and it includes all the negative and positive whole numbers, including 0. So, x is strictly greater than 2, or rather -2. -2 is an integer, but since x is strictly greater than -2, we can't include -2. The next integer greater than -2, of course, is -1. So we need a dot at -1. Then, of course, we have 0, 1, and 2. And here it says x is less than or equal to 2. So we have to include 0, 1, and 2. In F, x is greater than -1, so strictly greater than -1, and also strictly less than 3, so in between -1 and 3, and x is a natural number. Now, we know the natural numbers are represented by the numbers 1, 2, 3, etc. X is greater than -1, strictly greater than -1, so we can't include -1. In any case, -1 is not a natural number. Neither is 0. Then the next natural number, or the first natural number greater than -1, is 1. So we need a dot at 1. Then we also have 2. 2 is less than 3, and it's a natural number. So we need a dot at 2. We can see that x is strictly less than 3. So although 3 is also a natural number, we can't include 3. In question 3, it says solve each inequality below. Also draw the solution on a number line for questions A to E. So let's look at A. We can take the 4 to the right-hand side, and it becomes -4. So we're subtracting 4 on the right-hand side. And then, of course, m will be less than 7 minus 4, which is 3. We can put this on a number line. In this case, we have m and not x. So x is less than 3. It means that we have to draw the arrow to the left-hand side, or towards the left-hand side of 3. In other words, for numbers smaller than 3. And m is strictly less than 3, so we need a circle to show that we are not including 3. Here we have x minus 1 greater than or equal to 5. We want to isolate x on the left-hand side, and we can do so by taking the -1 to the right-hand side, and becomes +1. So we end up with x greater than or equal to 6. Then, showing this on a number line, it says greater than or equal to 6. So that means we must include 6. So we'll need a dot here at 6. Then, to show x greater than 6, we need an arrow pointing to the right of 6, to show that we're including all the numbers greater than 6. Then in C, we have 2y minus 3 less than or equal to -9. We want to isolate the y on the left-hand side, and we can do so by taking the -3 to the right-hand side. It becomes +3. So we end up with 2y less than or equal to -6. We want to get rid of the 2 here. So since we are multiplying by 2 on the left-hand side, we can divide by 2 on the right-hand side. So the answer is y is less than or equal to -3. Let's draw the number line. Now in this case, the variable or unknown is y. Its y is less than or equal to -3. So we need a dot at -3 to show that we are including it. Then we have less than -3. So we need an arrow pointing towards the left of -3. We want to isolate the y on the left-hand side of the inequality. So we can start by taking the 9 to the right-hand side, and it becomes -9. So 4y is greater than -8. We are multiplying by 4 on the left-hand side, and that means we can divide it into the right-hand side. So then our answer is y is greater than -2. Let's look at the number line. The variable here is y, and then we have -2. Now, y is strictly greater than -2, so we must exclude -2. So we have a circle at -2 to show that we are excluding negative 2. Then y is greater than negative 2, so the arrow must point towards the right of negative 2. In other words, for values greater than negative 2. Then in E, we have 7 is less than 1 minus 3t. We want the letters to be on the left-hand side and the numbers to be on the right-hand side. So we're going to bring the negative 3t to the left-hand side, and it's going to become positive 3t. At the same time, we can take the 7 to the right-hand side, and it becomes negative 7. So then 3t is less than negative 6. We can divide the 3 into the negative 6. And we see that t is less than negative 2. Let's draw a number line. Now t is strictly less than negative 2. So we need a circle at negative 2. And it is to point to numbers smaller than negative 2. Once again, we want to isolate the letter, in this case Q, on the left-hand side. So we can first take the 3 here to the right-hand side, and it becomes negative 3. There's a plus here, of course, that we don't write. So the positive 3 here, when we move it to the right-hand side of this inequality, it becomes negative 3. Now we want to get rid of the negative 2 here, so we can divide it into the right-hand side. But now, very important for inequalities. Whenever we divide or multiply an inequality by a negative number, it switches around. So we're going to divide the negative 2 into the right-hand side. So this inequality now becomes greater than or equal to. And then, of course, y is greater than or equal to negative 1. In this inequality, the letter is on the right-hand side. And we always want the letter to be on the left-hand side. So we're going to bring the 3t here to the left-hand side, and it becomes negative 3t. At the same time, we can take the 4 to the right-hand side, and it becomes negative 4. Now we want to get rid of the negative 3 here, so we're going to divide it into the right-hand side. But now, important to remember that when we divide or multiply an inequality by a negative number, this inequality will switch around, or the inequality will switch around. So when we divide the negative 3 into the right-hand side, it now becomes greater than. So greater than negative 3 over negative 3. And of course, this is greater than 1. We first get rid of the 2 on the left-hand side by moving it to the right-hand side. And of course, it becomes negative 2. Now we want to get rid of the minus here. Now, just remember that negative m actually means negative 1 times m. So we can get rid of this negative on the left-hand side by dividing negative 1 into the right-hand side. So then m, and as I said, we're going to divide the negative 1 into the right-hand side. So we'll get 3 over negative 1. But since we are dividing by a negative, the inequality must switch around. So it becomes less than or equal to. And then our final answer is m is less than or equal to negative 3. So here we have letters on both sides of the inequality. And we always want all the letters to be on the left-hand side. So we're going to bring the 3t to the left-hand side. And it becomes negative 3t. The negative 4 we're going to take to the right-hand side. And it becomes positive 4. So on the left-hand side, we have 2t. And this is less than 10. Now we simply divide the 2 into the right-hand side. and we end up with t less than 5. We want all the letters to be on the left-hand side, so the 5p we can bring to the left-hand side, and it's going to become negative 5p. At the same time, we can move the negative 3 to the right-hand side, and it becomes positive 3. P minus 5p is negative 4p. And then finally, we want to get rid of this negative 4 here. So we're going to divide it into the right-hand side. But since we are dividing by a negative number, this inequality will switch around. And so p is less than negative 2.5. We're going to start by multiplying out the brackets on both sides. So we're going to multiply like this. So 7 times p is 7p. Then we have the plus. 7 times 2 is 14. 4 times p is 4p. Then the minus. And 4 times 3 is 12. Now we bring all the letters to the left-hand side. So 4p to the left-hand side becomes negative 4p. And at the same time, we're going to move the 14 to the right-hand side. So it becomes negative 14. 7p minus 4p is 3p. And this, of course, is negative 26. Then finally, we can divide the 3 into the right-hand side. And we get negative 26 divided by 3. This, of course, we could do on a calculator in order to get a decimal. We're going to start by multiplying out the brackets on both sides. So on the left-hand side, we're going to get 2a minus 6. And on the right-hand side, we're going to get 3a plus 6. Now we're going to bring the 3a to the left-hand side. It becomes negative 3a. And this negative 6, we're going to take to the right-hand side. And it becomes positive 6. So 2a minus 3a is negative a. So that's going to be greater than 12. We want to get rid of this minus here. Now remember that negative a actually means negative 1 times a. So in order to get rid of the negative here, we divide the negative 1 into the right-hand side. So we're going to get a, and then we're going to divide the 12 by negative 1. And then to remember, so important to remember that when we divide an inequality by a negative number, it switches around. So here we're dividing the negative 1 into the right-hand side, and the inequality here becomes less than. And then finally, a will be less than negative 12. We can start by getting rid of the negative 5 on the left-hand side. And we can do so by taking it to the right-hand side. So of course it becomes positive 5. Now we want to get rid of the fraction here. And since we are dividing by 2 on the left-hand side, we can multiply by 2 on the right-hand side. So 12 times 2 is 24. We are multiplying by 3 here on the left-hand side, so we can divide by 3 on the right-hand side. And of course, t will be less than or equal to 8. We can first get rid of the 1 on the left-hand side by moving it to the right-hand side. Of course, it's going to become negative 1. Now we can get rid of the 3 on the left-hand side, and since we are dividing by 3 on the left-hand side, we can multiply by it on the right-hand side. So negative 3 times 3 will give us negative 9. Now we want to get rid of the minus in front of the x here, and remember that negative x actually means negative 1 times x. So to get rid of the negative 1 here, we divide it into the right-hand side. But then important to note, since we are dividing by a negative, the inequality will switch around. So negative 9 divided by negative 1 is positive 9. Here we can first get rid of this fraction by multiplying through by 5. So 5 times 4 is 20. Then 5 times 3x is 15x. And on the right-hand side here, when we multiply by 5, the 5's will cancel. So what we're saying is that multiplying the right-hand side here by 5 will make the 5's cancel. And we're left with 6 minus x. Now we bring all our x's to the left-hand side. So moving this negative x to the left-hand side will make it positive x. And the 20 here we can move to the right-hand side and it becomes negative 20. Negative 15x plus x is negative 14x. 6 minus 20 is negative 14. Finally, we can divide this negative 14 here into the right-hand side. And our inequality will switch around. So it becomes less than or equal to. Negative 14 divided by negative 14 is positive 1. In question 4 here it says, find the positive integers that satisfy this inequality. So let's first solve the inequality. We want to get all the letters on the left-hand side. So we're going to move the 3t to the left-hand side, and it's going to become negative 3t. At the same time, we want the numbers to be on the right-hand side. So we're going to move the 2 to the right-hand side, and it's going to become negative 2. So t minus 3t is negative 2t, and negative 6 minus 2 is negative 8. Now we can divide the negative 2 into the right-hand side, and our inequality will switch around. So negative 8 divided by negative 2. And then we see that t is less than 4. Now it says find the positive integers that satisfy this inequality. So which positive integers are smaller than 4? And we can write the answer in set notation. So t will be an element of course, the smallest integer that's less than 4 will be 1, or the smallest positive integer less than 4 is positive 1, then 2, and then 3. Note that t is strictly less than 4, so we won't include 4 as part of our answer. In question 5 it says, find the smallest integer value of p for which the following inequality is true. So this inequality. Let's first solve the inequality. We can take the 3 to the right-hand side and it becomes negative 3. Now we want to get rid of this negative 2 here, and we can do so by dividing it into the right-hand side. But then of course our inequality will switch around. And that's because we are dividing by a negative number. So we end up with p greater than negative 1. Remember, we must find the smallest integer value of p for which the inequality is true. So let's just revisit the integers. So the integer z will be negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. So the smallest integer value of p, we know here that p must be greater than negative 1. So which integer comes after negative 1 but is greater than negative 1? And of course the answer is 0. So p is equal to 0. Then in number 6 it says, find the greatest integer value of x for which the following inequality is true. So this inequality, we can first solve the inequality. So we can take the negative 4 to the right hand side and it becomes positive 4. Now we can divide the 2 into the right hand side. And of course, x will be less than or equal to 4.5. Now, we need to find the greatest integer value for which this inequality is true. Now, if we illustrate this on a number line, you may understand it better. It says x is less than or equal to 4.5, so it includes 4.5. But we need to find the greatest integer value of x for which this is true. Now, the integer just before 4.5, of course, is 4. So our answer here then, x is equal to 4.